So the chapter name is Laws of Motion. So in this chapter, you will learn all the laws associated with the motion. All the laws associated with the motion, and and also you will learn the derivation of force, okay, friction, etc. So laws of motion, there are three laws, okay. There are three laws. What are the three laws, Trisha? What is your name, Trisha? And tell me your name. Trisha, പിന്നെ name
Name,
പേരെന്ന് പറഞ്ഞേ.
the my full name.
Ah, okay, okay. So laws of motion, this chapter begin with Newton's first law of motion, okay. I don't want to give you introduction because there is no time to spend on introduction part. Let me begin the chapter directly. The laws of motion, the chapter starting with the theorem, Newton's first law of motion. Can you tell me, anybody, can you tell me what do you mean by Newton's first law of motion? Anybody? Trisha, tell me what is the Newton's first law. You have studied in the lower classes also, right? You studied in even in 9th standard you studied, right? Let me join from my mobile so that I can watch you. I can watch you. So let me join the class from my mobile also. Diya and Trisha. Okay. So Newton's first law, nobody has the answer. So let me explain that. Newton's first law says that, suppose this is a ball. Okay, you can see the screen. Can you see the screen? No, you cannot see the screen. Sorry, I forgot to share my screen. Sorry. Let me share the screen. Now you can see the screen, right? Clear?
Yes.
Okay. So please write the name of the chapter, Laws of Motion. Please write. Please write the name of the chapter, Laws of Motion. Written. Laws of motion. This is the fourth chapter. Written.
Yes, sir.
Okay. So Newton's first law of motion states that, suppose this is a ball. Look at the screen. Look at the screen. Suppose it is a ball. Okay. Suppose if I applying some force on this body, then if there is no other force, or it has a initial speed, this ball has some initial speed. If there is no force acting on this body, then it will go like this, moving in a straight line, and the speed remains the same. So every body continues to be the state of rest or the state of uniform motion in a line, unless there is no unless an external force applying on it. Suppose this body is moving with a speed 5 meter per second. This body has a starting speed 5 meter per second. If no force acting on this body, its speed will be always 5 meter per second, and the motion will be in along a line. Understood? Clear? Okay, I hope you have understood. The statement I will repeat, don't worry, I will repeat. So the Newton's first law says that if there is no force, it will be continue to be rest, or it will move along a line. Okay, 1 minute. This one, I am talking about this one. Okay, this one. Now suppose there is a force, I am acting some force in this direction. For example, a wind is blowing in this direction. A wind is blowing in this direction. Okay, understood. And suppose this body, suppose 1 minute. Suppose this object is moving with some speed. If there is a force in this direction, its velocity will be changed. Have you understood? It will deviate from the straight path if there is any external force. If there is any external force, the body will be deviated from the straight path, or its speed will be changed if there is an external speed. If no external speed, it will continue in a straight motion. Speed remains the same. If there is some external force, what happens? Its speed will be changed. Understood? You can see that its velocity is changed. Velocity will be changed. Have you understood? Clear?
Yes, sir.
Trisha understood. For example, a wind is blowing. No, of course, the body will be deviated from the its actual path. So the definition of Newton's first law statement is this. The statement of Newton's first law is this: every body continues to be in its state of rest. If the ball is stationary, it remains stationary if no force acting on it. If the body is at rest, remains at rest. If the body is moving with the speed, remains moving with the same speed if no external force. If there is any external force, its velocity will be changed. So every body continues to be its state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. Understood? All of you clear? Trisha, Dia, understood?
Yes, sir.
Okay, so please write down this. You need not draw this picture. No need to draw this picture. Okay, please write the statement. The statement is important. Okay, and if you want to write it later, you can do that. Okay, I will send the PDF after the class. ഓക്കെ ദിയക്ക് എന്തെങ്കിലും ഡൗട്ടുകളൊക്കെ ഉണ്ടെങ്കിൽ ചോദിക്കാം കേട്ടോ. ദിയ കേട്ടല്ലോ? ദിയ ഇതിങ്ങനെ വൺ സൈഡ് ആയിട്ടല്ല പോകുന്നത്. നിങ്ങളുടെ അടുത്ത് ഡൗട്ട് ചോദിച്ചിട്ട് അടുത്തതിലോട്ട് പോകുന്നുള്ളൂ. തൃഷ, യു ക്യാൻ ആസ്ക് ഡൗട്ട്. ഓക്കെ തൃഷ,
Yes.
tell me if you have written the statement. Don't draw the picture.
കഴിഞ്ഞു.
Completed അല്ലേ? ദിയയുടെ കംപ്ലീറ്റ് ആയല്ലോ അല്ലേ? തൃഷ
Done.
done. Okay, next is momentum. What do you mean by momentum? Anybody? Trisha or Diya? Will you please tell me what do you mean by momentum?
Mass into velocity.
Mass into velocity. Yes. What is the significance of momentum? Significance of momentum is, I will explain that. Significance of momentum. Suppose this is a stone. You can see a small round shape. Correct? Suppose it is a stone. Okay. And here there is a mango. I want to throw the stone to take the mango. Okay, I want to throw the stone to take the mango. So I want to throw the stone. I want to throw the stone. So the more speed, the more mangoes will be falling down. Understood? If the stone speed is larger, then the more mangoes will be falling down. Is that correct? All of you clear? The more speed, the speed has a significance on impact. Impact means collision will be stronger. The more speed, the more stronger collision, so the more mangoes will be falling down. And also the stone, if the mass of the stone is larger, then also the impact will be larger. Alle ശരിയല്ലേ? If the mass is larger, if you take a big stone, the more mangoes will be falling down. So mass has a role in the impact or collision. Speed also has the impact. So mass and velocity. So the product of mass and velocity is very important term associated with the motion. Mass into velocity, the reason is this: the more velocity, the more mass, the more impact on collision. The more velocity also results in more impact in collision. So mass into velocity is very important term associated with the motion. let us say mass into velocity, it is called momentum. I have written that momentum of a body roughly represents the strength of the motion. Clear? The momentum of a body represents the strength of the motion. It is defined as the product of mass and velocity denoted by P. Clear? Understood? Okay. Have you understood? Trisha, have you understood momentum? Okay.
Yes, sir.
So P equal to m into V. Velocity is a vector quantity. You understood that. You have studied that. Velocity has a direction. Understood? If you throw the stone, the direction is important. You can throw the stone like this, or like this, or like this. So velocity has a direction. Okay, direction. So mass does not have any direction, but velocity has a direction. As a result, momentum also has the direction. Both momentum and velocity are the vector quantities. Clear? Since velocity has direction, momentum has direction. Direction of momentum is same as that of velocity. It's very, very important. Direction of momentum is same as that of velocity. Understood? The momentum is okay. All of it clear? Trisha, Diya, understood? Momentum.
Yes, sir.
Momentum is clear. Okay, momentum is a vector quantity. I hope you have understood. So please write a heading momentum. No need to draw this picture. Okay, no need to draw this picture. Please write momentum of a body is defined to be the product of mass and velocity. P equal to mv. Momentum is a vector quantity. Please write. Picture വരയ്ക്കണ്ട കേട്ടോ. No need to draw the picture.
എഴുതി കഴിഞ്ഞു.
Diyada complete ആയി.
Done, sir.
Done. Yes. Okay, so we have studied Newton's first law, and we have studied momentum also. Momentum means strength of motion. Okay. Then next is Newton's second law of motion. Statement is very, very important. So anybody, can you tell me what do you mean by what is Newton's second law of motion? Trisha or Diya, tell me.
Rate of change of momentum is proportional to
Ah.
force acting.
Rate of change of momentum, right? Rate of change. Okay. Yes. Newton's second law of motion. The statement is important. I will read it. The rate of change of momentum of a body is directly proportional to the applied force and take place in the direction in which the force acts. Have you got any idea? Trisha, have you got any idea? No.
Yes, sir. I understand.
Okay. Actually, it is already taken your school, so I don't want to spend more time on these things. Okay. So this means that, listen, suppose there is an object. Say for example, a ball is there. It is kept on a smooth surface. There is a ball which is placed on a smooth surface. Okay. Suppose it is moving with some speed, say initially 5 meter per second. Just an example. Okay. Within a short time period, the speed reaches 10 meter per second. Let the mass remains the same. There is a body. Initially, it was moving with a speed 5 meter per second. Within a small period of time, the speed becomes 10 meter per second. what does it mean actually? That means that somebody is pushing this ball, clear, somebody is applying some force, that is why the speed is increased, clear? You got my point? Understood? Okay. So initially the momentum is changed, clear, somebody is pushing this body, that's why the momentum, you can see the change in momentum. The initially the momentum was 5 into mass into velocity. The momentum, you can see that there is a change in momentum. So the change in momentum in 1 second, clear, change in momentum in 1 second, that is proportional to the applied force. So the derivation using Newton's second law, we can derive the formula for force. So some force is applied that results in change in momentum. Okay, so I want to derive the formula for force. Okay, so change in momentum. Suppose a body has, let me draw some picture here, m, a body having mass m, it is moving with the initial speed, let it be u, initial speed u, and after some time the body's velocity is changed to v. Why? Because somebody is applying some force from the side. I am applying some force. So let the mass remain same. Let the mass remains the same. So what is change in momentum? Can you let me write in a single step? And also, okay. What is the change in momentum? Can you tell me change in momentum? Change in momentum is equal to final momentum minus initial momentum. Trisha, are you clear? Change in momentum will be final momentum minus initial momentum. Is that correct?
Yes.
Final momentum mass into velocity, right? M into v. This is the final momentum minus initial momentum will be m into u. This is the change in momentum. And suppose this momentum change happens, clear, this momentum change happens in a small time interval, say time t. This momentum change or velocity change took place in a small time interval t. So the statement says that rate of change of momentum. What is that? Rate of change of momentum. Rate of change of momentum. Momentum means in 1 second how much change in momentum? In 1 second. In t seconds this much change happens. In t seconds this much change happens. So in 1 second how much change? mv minus mu divided by t. Correct. I will repeat. In t seconds this much change happened. T second. So in 1 second how much change will be there? mv minus mu divided by t. Clear? Trisha, Diya, all of you clear?
Yes.
ദിയയ്ക്ക് മനസ്സിലായോ ദിയ പറഞ്ഞത്?
മനസ്സിലായി.
So this law states that this one, rate of change of momentum proportional to the applied force. Okay, so I told you that I have applied some force, because of that change in momentum take place. So the law states that the force F is directly proportional to the rate of change of momentum. I mean mv minus mu divided by t. The law says that F is proportional to rate of change of momentum. Let me simplify this expression. F directly proportional to. Do you know the meaning of directly proportional to? Trisha, Diya, do you know the meaning of directly proportional to?
Yes, sir.
അറിയാലോ അല്ലേ? I mean Trisha, you know the meaning, right? Trisha, okay. So here let me do one thing. M is common in the numerator. The two terms contains m. I can take m outside. M is common, hence m is taken outside. V minus u by t. is remaining. Okay, one more step. F directly proportional to m into, what is this? V minus u is the change in velocity, alle correct? V minus u is the change in velocity. V minus u by t എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ rate of change of velocity, correct? V minus u by t എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is simply change in velocity by time. Change in velocity by time is said to be acceleration, correct? ശരിയല്ലേ ദിയ, തൃഷ? Understood? Change in velocity by time is called acceleration. So F is directly proportional to ma. In general, what is to be done? If the proportionality symbol is removed, I can put the equal sign, but in the right side I have to put some constant k in the right side. If you want to remove the proportionality symbol, then you have to put a constant, some constant in the right hand side. Is that clear, Diya, Trisha? Okay. K can be any number, okay, but once you fix the value for k, don't change it. I am defining force. I want to assign some suitable value for k. Once I assign the value of k, never change it. So to make the formula have a simple look, let me put k equal to 1. I am defining force in this way, okay? Let me put k equal to 1. So I will never change it. Every time I will put only k equal to 1. So if I put k equal to 1, f equal to 1 into ma or f equal to m into a. So we got one important formula for finding force. Force acting on a body equal to m into a. All of you clear? Understood?
Yes, sir.
And what is the unit of force? Can you tell me what is the unit of force? You have studied that. Unit of mass, kilogram. Unit of acceleration, meter per second square. Kilogram meter per second square. Kilogram meter per second square is denoted by Newton, N. Okay, Newton denoted by the symbol N. So the unit of force is Newton. Understood? All of you clear? Trisha, Diya?
Yes, sir.
Okay, so please write down, or you can write it later. Okay. Newton's second law of motion. So using Newton's second law, we can derive the formula for finding force.
Kilogram meter per second square നെ ന്യൂട്ടൺ എന്നാണ് പറയുന്നത്.
അതെ, കിലോഗ്രാം മീറ്റർ പെർ സെക്കൻഡ് സ്ക്വയറിന് ന്യൂട്ടൺ എന്നാണ് നമ്മൾ പറയുന്നത്, n. ഓക്കെ, ഡൺ. തൃഷ കംപ്ലീറ്റഡ്. ദിയാണ് കംപ്ലീറ്റ് ആയത്.
അല്ല, രണ്ടുപേരും കംപ്ലീറ്റ്.
കംപ്ലീറ്റ് ആയല്ലോ. ഓക്കെ. വാട്ട് അബൌട്ട് ദ ന്യൂമറിക്കൽസ്? ന്യൂമറിക്കൽസ് ഈസി ആണോ ദിയക്ക് ഈ ചാപ്റ്ററിലുള്ള? അതായിരിക്കും ഹാർഡ് അല്ലേ?
ന്യൂമറിക്കൽസ്
ചെയ്യാറില്ല. അത് കുറച്ചൊക്കെ ചെയ്ത് പഠിക്കണം. ഓക്കെ, നമ്മളൊന്നും ചെയ്യാതിരുന്നത് ശരിയാവില്ല. തൃഷ, ഹൗ ഈസ് ദ ന്യൂമറിക്കൽസ്? ഈസ് ഇറ്റ് ഹാർഡ്? Have you tried the numericals?
No, sir.
No. Okay, let us go through some important numericals. Okay, most of the questions will be numerical. Physics will be full of maths. This question is taken from textbook. You can see that 4.5. 4.5 indicate that this is fourth chapter and this is the fifth question, directly taken from NCERT textbook. Okay, so let me read the question. A constant retarding force, I will explain that. A constant retarding force 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? It is actually an indirect question. In physics, most of the questions will be indirect. Okay, so have you got any idea? Have you understood this question? Diya, Trisha?
question മനസ്സിലായി.
കുറച്ച് മനസ്സിലായി. Trisha, have you got any idea? Okay. So if you have not understood the question, the first step is draw a rough picture. If you don't draw the picture and read this question again and again, that will not going to help you. You must draw a rough picture. Okay, it's necessary. So drawing the picture like this, consider a ball, a body. Okay, like that. A body is there, it has mass. The drawing this picture is not difficult, right? A body has mass 20 kg, right? Initially it was moving with some speed. It has initial speed u. Initial speed always denoted by the letter u. You know that. U, initial speed, initially it was moving with the speed 15 meter per second. Till this step are you okay? Till this step are you okay? Clear?
Okay.
And I am applying some force. I am applying some force. Retarding force means I am applying some brake. Clear? I want to stop this body. In order to stop this body, I have to apply a force like this. Clear? I want to stop this body. Retarding means stopping force. Clear? I want to stop this body by applying some force, so that if I apply force like this, its speed will be gradually reduced. Correct? The speed will be reduced and finally the body comes to rest. Clear? The final velocity becomes 0. I am applying a fixed force every time. Till the body stop, I am applying a fixed force. Clear? After moving some distance, the body finally comes to rest. Understood? Trisha, Diya, clear? All of you clear? So our question is, how long the body traveled? That's the question. What is the distance traveled by the body? That's the question. So if you have drawn this picture, you got some idea. Otherwise you will not get any idea. So force is there. So here what we can do? Time അറിയില്ല. ഒരു മിനിറ്റ് പറയാം. So listen, this F is given, right? This F is given. Remember, the force is a vector quantity. First of all, please remember that force is a vector quantity, because the direction of the force is very, very important. I can apply force like this, or I can apply force like this. Understood? The force is a vector quantity. Its direction is very, very important. So the direction, if the applied force towards right, there is a sign convention. There is a sign convention says that if the applied force is towards right, it is written as positive. If the applied force is right, the force is positive. If the force left side, if the force applied towards left, it is the sign will be negative. Okay, 50 Newton. If you don't put the negative sign, you will get wrong answer. Okay, so the sign convention is very simple. If the force is towards right, force, velocity, acceleration, whatever towards right, it is taken as positive. Force, velocity, acceleration, displacement, whatever it is towards right, always taken as positive. And towards left, all physical quantities taken as negative. Clear? So here I am applying a retarding force. I want to stop it. So the force is applied towards left. I am applying a negative force, minus 50 Newton. Till this step are you okay? Trisha, Diya, Clear? Okay, so if the force is given, then you can immediately find the acceleration, because look here, we have studied that F equal to ma, right? We have studied that F equal to ma. Or if you make the arrangement, what you will get? F equal to ma you have already studied. If I take this m to the left hand side, you will get acceleration equal to F by m. Is that correct? Trisha, Diya, is that correct? Ah. So what I can say is this formula is much important compared to F equal to ma. A equal to F by m is the most important formula compared to F equal to ma, because in most of the problems I want acceleration. The force will be given. If the force is given, you can easily find out acceleration. So this formula is the most important formula. Okay, later cases also we will use this formula. Acceleration can be found if the force is available. Okay, so the force is available, so I can find the acceleration of the body. Correct? So I can easily find out the acceleration of the body. You must memorize this formula, F equal to ma or A equal to F by m. This is the most important one. Okay, A equal to F by m. F is what? What is force? Minus 50. Clear? The sign to be considered. And mass is 20 kilogram. Are you clear? Okay, Trisha, Diya, understood? So acceleration is minus 5 by 2. The sign is required. Meter per second square is the acceleration. So I got the acceleration of the body. Let me write here, acceleration minus 5 by 2. I got it. Is that okay? All of you clear? Okay, all of you clear? Then you studied the chapter motion in a straight line, correct? You studied the chapter motion in a straight line. In that chapter you studied kinematic equations like V equal to U plus AT. Do you remember that formulas? V equal to U plus AT. You look here. Here you are given U is available, A is available, V is available. Okay. U is available, acceleration of the body is there, final velocity is there. You have to find the displacement. How long, clear, how much distance it traveled. So you need the displacement. S is our question. S.
So we need to find time there, right?
How long does the body okay, I thought that it is displacement. Sorry, how long it will take. Okay, it was the question. So the time is our question. Correct? Understood? Clear? No response. Trisha, Diya, clear? Okay, so is there any formula connecting these highlighted terms? Is there any formula connecting these highlighted terms? UAVT. Is there any formula? UVAT. Even in 9th standard you studied this formula. V equal to U plus AT. Have you studied this formula? V equal to U plus AT. Trisha? Diya പഠിച്ചിട്ടുണ്ട്. Trisha? Okay. In the chapter you studied formulas. Okay. What are the three important formulas you studied in motion in a straight line? One is V equal to U plus AT. S equal to UT plus half AT square. അല്ലേ Trisha? Diya പഠിച്ചിട്ടില്ലേ? Diya ഉണ്ടോ? And one more formula is V square equal to U square plus 2AS. These three formula is very important in this chapter, laws of motion. Okay, without this formula you cannot do any problem. Okay, is there any formula connecting U, A, V, T? Yes, V equal to U plus AT. Trisha, are you clear? Trisha?
Yes.
V equal to U plus AT. Let me substitute the values. V equal to 0, correct? Final velocity is 0. Final velocity is 0. Acceleration is 5 by 2. Acceleration is 5 by 2. Final velocity is 0. 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 Final velocity is u is the initial velocity 15. Okay, a, what is this a is acceleration minus 5 by 2. T is the time taken. Okay, that's the question. Then a rearrangement. Okay, rearrangement means I can take this term to the left hand side. Clear? I can take that term to the left hand side. The simple step becomes 5 by 2t equal to 15. Is that okay? Clear? Okay, la? Diya, Trisha, understood?
Yes, sir.
Then I can do one thing. This 5 by 2 can be taken to the other side. Is there any issue? No problem. 5 by 2 becomes 2 by 5, reciprocal. 5 by 2 into nanalo. If you take 5 by 2 to the other side, it becomes reciprocal 2 by 5 into 15. I don't want to explain the simplification part. 6 seconds. So the body will stop in 6 seconds. Okay, all of you clear? Diya, Trisha, okay.
Yes, sir.
Okay, if you want to write the solution, please do it, or otherwise you can refer the PDF. Okay.
എഴുതി കഴിഞ്ഞു.
തൃശ്ശയുടെ കഴിഞ്ഞു. സോറി, ദിയ എന്നല്ലേ പേര് അല്ലേ? ഓക്കെ. തൃഷ,
Yes, sir. I'm also done.
okay, you have done or almost done?
Done, sir.
Done. Okay. Again, this is a numerical. I will discuss only selected numericals. Okay, I am not planning to discuss all numericals. Some important numericals I will cover. A constant force, 4.6. Can you see the screen? Trisha, Diya. A constant force acting on a body of mass 3 kg changes speed from 2 meter per second to 3.5 meter per second in 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude and direction of the force? Again, draw a rough picture like previous question. Just draw a rough picture, then you will get a good clarity about the problem. Otherwise you will be reading this problem again and again. There is a body having mass 3 kg. We have a body having mass 3 kg. Yes. Changes speed from 2 meter per second to 3.5 meter per second. This body has the initial speed u equal to 2 meter per second. This body has initial speed 2 meter per second, and it is changed to the final speed. The final speed of the body becomes 3.5 meter per second. You can see its increase in speed. The increase in speed due to some applied force. Some force is applied. As a result, the force, speed is increased, right? The final speed is this. Okay. The time taken for the change in speed is given as 25 seconds. The direction of the motion, okay, remains unchanged. What is the magnitude and direction of the force? F is the question. So question is clear? Understood? Diya, Trisha. Since the question is F, you can directly start with the formula. Understood? Since the question is find the value of the force, let me directly start with its formula. You studied that F equal to m into A. F equal to m into a. Let me go in this way. Okay, m into. You know, acceleration is change in velocity by time. Correct? Diya, Trisha. Acceleration is what? Change in velocity by time. Change in velocity will be v minus u. Final minus initial. Change in velocity by time. That is acceleration. Then you simply substitute the value. This is very simple question. You just substitute the values. M equal to 3 into v is 3.5 minus u is 2 by time 25. Clear? Diya and Trisha understood this question?
Yes.
Shall I discuss the multiplication and division step? You can do it later, okay? Multiplication and division step, you can do it later so that we can save time, okay? I want to save time. You do this calculation, I will write the answer. You can do the calculation later. 0.18 Newton. Clear? Method is clear to you. Understood? Method is clear?
Kitty.
Kittiyallo. Okay. The positive sign indicate that. The positive sign indicate that towards right. Okay. The force as per this picture towards right. Okay. Towards right. The positive sign indicate that the force, the direction of the force is towards right. So it's a very simple question. Alle? Trisha, Diya.
Yes, sir.
So you need not worry about the numericals. Only thing is, പറഞ്ഞോ.
ഇനി വരച്ചേക്കുന്ന വെച്ചല്ലേ റൈറ്റ്, അല്ലെങ്കിൽ ഫോഴ്സിന്റെ ഡയറക്ഷനിലാണോ?
ഇങ്ങനെ വേണമെങ്കിൽ പറയാം, ആസ് പെർ ദ പിക്ചർ ദ ഡയറക്ഷൻ ഓഫ് ദ ഫോഴ്സ് ടുവേർഡ്സ് റൈറ്റ് ഓർ the force towards the in the direction of the motion. Okay, we can say like that. Force in the direction of the motion. Alle correct alle? Direction of the motion. Clear? The force is in the direction of the motion. Clear? Clear ആയില്ലേ? Okay, Diya, Trisha, please write the solution or do it later. ചില ക്വസ്റ്റ്യൻസ് ഭയങ്കര ലെങ്തി ആയിരിക്കും കേട്ടോ, അതുകൊണ്ട് ഞാൻ പറയുന്നതാണേ. കഴിഞ്ഞു. Trisha. This question I have done earlier. This will be homework for you. I think if you draw the picture, I think you will be able to solve this question. Okay, if I discuss all the problem, it will take too much time. So you can do one thing, take the screenshot of this question. Please take the screenshot, or please write the reference 4.8. I told you this question is taken from NCERT textbook. Please write the reference 4.8 or take the screenshot. It is a homework for you. You need to send me the solution tomorrow. Okay? Basically F equal to MA is required. Okay? Try this problem. I mean not now, homework. If you are not getting, I will discuss in the next class. Okay? Trisha, Diya.
Okay, sir.
Noted. Can I go to next page? A few questions I will discuss. Some of the question will be homework for you. Okay. This question is taken from solved example, textbook solved example. This is very important question. It's a famous question, very important one. So that I would like to discuss this question. Very important one. I think the similar question is there in chapter work energy power. I think so. A bullet of mass 0.04 kg moving with a speed 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? Have you understood this problem? ദിയയ്ക്ക് മനസ്സിലായി. Trisha, have you understood this problem?
Yes.
Okay, let me draw a rough picture, then you can understand that. We have a wooden block. Okay, it has a sufficient thickness. There is a wooden block having a sufficient thickness. Wooden block. A bullet is there. A bullet is very small in size, you know. A bullet is about to penetrate this wooden block. Clear? About to enter the wooden block. Just about to. Okay, about going to. I mean, it is about to collide with the wooden block. Let it be here. Okay, this is the bullet moving like this. Okay, the mass of the bullet is given. Mass of the bullet is 0.04 kg. The bullet has the mass 0.04 kg and its initial speed just before collision, its initial speed is 90 meter per second. Is that okay? Clear? Understood? Now it is just entered the wooden block. As a result, its speed gradually reduced. Clear? Understood? Its speed will be gradually reduced and finally it stopped because of the resistive force. Clear? The wooden block apply some frictional force or resistive force. Frictional or a resistive force acting on the bullet. As a result, its speed gradually, reduced, and finally it stops somewhere. Clear? Final velocity 0. Is that okay? Clear? During this time, the bullet traveled how much distance? The bullet traveled inside the wooden block. The bullet traveled displacement S equal to, is it given? 60 centimeter. Wooden block traveled 60 centimeter. Bullet traveled 60 centimeter inside the wooden block, and finally it comes to rest. What is the force? The force, frictional force applied by the wooden block is our question. Okay, Trisha, Diya, both of you, question is clear? F is our question. F equal to m into a. You know that. F equal to m into a. Mass into acceleration. Here, this bullet has acceleration. The velocity is decreasing, means that the acceleration will be negative. I want acceleration because then only I can find out force. Because force equal to m into a. Mass is there, but acceleration is not there. Acceleration, can I find acceleration? Anyway, can you see the screen? Can you see the screen?
Yes, sir.
Okay. Look here. U is available. V is available. Understood? Please note the letters. U is there, V is there, S is there. Understood? U, V, S. A I want. I want A. Because why I need A? Then only I can find out force. U, V, S, A. Is there any formula connecting all these letters? UVAS. You just highlight and tell me, is there any?
V square is equal to
Ah,
V square plus
yes,
2AS.
yes. You look at the letters, then identify the formula. UVAS. We have a formula that ദിയക്ക് മനസ്സിലാവുന്നില്ല പറയണം. We have a formula V square equal to U square plus 2AS. ഇങ്ങനെ ഒരു ഫോർമുല പഠിച്ചിട്ടില്ലേ ദിയ? എവിടെ എഴുതി തന്നിട്ടുണ്ടല്ലോ, എവിടെ എവിടെ എഴുതിയിട്ടുണ്ട്? V square equal to U square plus 2A. V square equal to U square plus 2AS. I want acceleration. So V square, V is 0. Final velocity 0. Yeah. U square. U is 90. Correct? U is 90. U square will be 90 square. Then next 2AS is there. 2AS. 2A. A I don't know. S. Many students make mistake that they don't care about the unit. You know, the distance is the unit of the displacement is meter. Correct? Diya, Trisha, the unit of displacement is what? Meter. How will you convert centimeter to meter? How will you convert centimeter to meter?
100 centimeters is equal to 1 meter.
If you want convert centimeter to meter, do one thing, dividing by 100. Okay, that's all clear. Very simple technique. Centimeter can be converted to meter. How? By dividing by 100. Please memorize that. 60 by 100 meter എന്ന് എഴുതാം. Trisha, Diya, clear? Okay.
Yes, sir.
It is 0.6. And remember, I don't want to explain the calculation. Okay, I want to cover maximum topics. So I don't want to spend time how to multiply 2 and 0.6, how to divide that part I don't want to discuss. You can do that after the class. So 2 into A into S is there. S is 0.6. Clear? All of you clear? Understood? Okay. Diya, clear? Trisha? Hello? Audible? Hello, is it audible? Hello? Is it audible? Hello?
Yes, sir.
There is a network issue. Trisha, Diya, is it audible? Your voice is not properly audible. 0 equal to 90 square. 90 square is 8100. 2 into 0.6 will be 1.2. A. Clear? Diya, Trisha, is that okay? Clear?
Yes.
Making the rearrangement. 1.2A equal to minus 8100. I want acceleration because I want force. 1.2A equal to minus 8100. You must take care of the unit. Unit is very, very important. So acceleration is minus 8100 by 1.2. Is that okay? Trisha, Diya, clear? How will you do the division? Can you tell me? How will you do this division? Cut ചെയ്യണം. ഞാൻ പറഞ്ഞുതരാം. Actually, if the point is there in the denominator side or numerator side, the better is you remove that decimal, I mean point. You better remove the point, otherwise the division will be very hard. So let me multiply numerator and denominator by 10 so that I can avoid the decimal point. Clear? So minus 81000 and in the denominator the decimal point is removed. I got 12. Is that okay? Diya, Trisha, is that okay?
Yes.
Then I don't want to discuss how to do this division. Okay, that part you can do it later. Let me write the value of the division. What is that? 8100. 8100 divided by 12. 675, sorry, minus 6750 meter per second square. You can do the division later. So I got acceleration as minus 6750. Clear? All of you clear? Understood?
Kitty.
Force, I want force. The frictional force exerted by the wooden block. F equal to m into a ആണല്ലോ. Mass into acceleration. Mass of the bullet. Mass of the bullet is 0.04. Acceleration is minus 6750. Let me multiply this number. 0.04. You will get minus 270 Newton. Minus sign indicate that the force towards left. Clear? Yes, force is towards left. All of you clear? Understood?
Yes, Kitty.
Okay, please write out. Okay,
Easy, sir.
completed. Diya completed. Trisha?
1 minute, sir.
Okay, please write, please.
Done.
Done. So now it is 1 hour. So let me wind up the class. Next topic is impulse. I will explain the impulse in the next class. Tomorrow's time I will message you. So let me wind up the session. The recorded class is available. I will send it later. I will send the PDF. Okay, PDF file right now. So let me wind up the class. Okay, Diya, Trisha. Okay,
Okay, sir.
okay, okay then.